Hello, welcome back once again to another video. So today we're going to integrate x divided by the square root of x squared minus 4 dx, right? So how exactly are we going to integrate this function, right? Okay, now let's play this trick. Let's call this integral I, right? So we can say that I is also the same as, if you say 1 over 2 multiply by, then we need to have 2 right over here, right? Because 1 over 2 times 2 will give us 1. And here we have x. So this is divided by the square root of x squared minus 4, then dx, okay? Now we're going to make a substitution, so we're going to let u equals x squared minus 4. So you can see that du will be equal to 2x dx, okay? So this integral I is also the same as 1 over 2 multiplied by the integral of, we can write this as 2x dx up here, then divided by the square root of x squared minus 4. So now to make our substitution, so this is going to be equal to 1 over 2 multiplied by the integral of 2x dx is du, right? So we have du up here, then divided by the square root of x squared minus 4 is u, right? So we get I is equal to 1 over 2 multiplied by the integral of 1 over u to the 1 over square root of u is same as u raised to the power of negative 1 over 2, right? Then we have our du. Then use this standard formula. We know that the integral of x raised to the power of n with respect to x is equal to x to the power of n plus 1 divided by the new exponent n plus 1 plus constant c. So we're going to use that here. So we're going to get I is equal to 1 over 2, so multiply by u raised to the power of negative 1/2 plus 1 divided by negative 1/2 plus 1, then plus c. So this will be equal to 1 over 2. So negative 1/2 plus 1, that will give us 1/2, right? So we have u raised to the power of 1/2, then divided by 1/2 plus c. So remember that at the denominator, the 1/2 we flip, right? So this will be 1 over 2 multiplied by, so it will turn out to be 2 over 1, then multiply by u raised to the power of 1 over 2, right? Then plus c. So for which this, we cancel this, and we're left with u raised to the power of 1 over 2, which is square root of u, and then plus c. So do not forget, we're going to get our solution in terms of x, right? So and u is equal to x squared minus 4, so therefore we can say the integral of x divided by the square root of x squared minus 4 dx is equal to square root of x squared minus 4 plus c. So this right over here is our solution. Okay, now let's talk about something very nice. Let's say we have the integral of the derivative of a function f prime of x divided by the square root of the function itself, f of x. Okay, so now let's see if we can get a closed form for this type of integrals, right? So if you make the substitution, letting f of x, right? So letting f of x, so let me erase that. So let's start with the substitution. So we're going to let f of x equals y, okay? So differentiate both sides, so we'll get f prime of x dx is going to be equal to dy, right? So the integral now will become, so that will become the integral of f prime of x dx, that is dy, right? So divided by the square root of f of x, which is y. So this will be equal to the integral of y raised to the power of negative 1/2, then dy. So this will be y to the power of negative 1/2 plus 1 divided by negative 1/2 plus 1 plus c, right? So at the bottom there, we just have 1/2, which we flip. So we're going to have just 2 times the square root of y and then plus c. So remember, y is f of x, right? So we get 2 times the square root of f of x, then plus c. So now we can say that the integral of f prime of x divided by the square root of f of x dx is equal to 2 multiplied by the square root of f of x plus c. So, but what about the application? So let's say we have the integral of e raised to the power of x divided by, so let's say we have here the square root of e raised to the power of x plus 5, and we need to integrate this, right? So if you carefully look at this, you will see that here our f of x is equal to e raised to the power of x plus 5, and again our f prime of x is awesome, right? It is e to the power of x, the stubborn guy. Okay, so now take a look. You will see that this integral is in this form, right? So which means that this integral will be equal to 2 times the square root of f of x, which is 2 times the square root of e to the power of x plus 5 plus c. So you can see we just quickly get the solution. Okay, let us look into one more integral. So say we have to integrate, let's say we have x raised to the power of x into bracket. So let's say we have 1 plus the natural log of x, and down here we have square root of x raised to the power of x, right? So this one looks a little bit weird. Okay, so now do you observe that the derivative of x to the power of x is x to the power of x into bracket 1 plus natural log of x? So we can say that our f of x here is equal to x raised to the power of x, right? And therefore f prime of x is equal to x to the power of x into bracket 1 plus natural log of x. So you know what happened? Let's prove that this is true, right? So we have y is equal to x raised to the power of x. Take the natural log on both sides, so we get the natural log of y is equal to the natural log of x to the power of x. So from here we get with the property of logarithm, so this will be natural log of y is equal to x multiplied by the natural log of x. So we're going to differentiate both sides, and at the right hand side we're going to use the product rule, since we have the product of two different functions, x and natural log of x, right? So remember that y is being treated as a function of x. So at the left hand side we're going to have, you know, the derivative of natural log of y will give us 1 over y, then we have our dy dx, right? So this will be equal to, so this right over here is, we're going to use the product rule. So first we need to have fx prime multiplied by the natural log of x, then plus we're going to have x multiplied by natural log of x prime. So here we get 1 over y multiplied by dy dx. So this is equal to, the derivative of x is 1, so we get natural log of x from here, plus, so here we have x multiplied by the derivative of natural log of x will give us 1 over x, and we have this nice cancellation here. So now we're going to have here 1 over y multiplied by dy dx. So this is equal to, down there be the right hand side, so we have just natural log of x plus 1 multiplied both sides by y, we get dy dx is equal to y into bracket 1 plus natural log of x, and do not forget y is x to the power of x, so we get x raised to the power of x multiplied by 1 plus natural log of x. So that is exactly the derivative. So with that idea, now we can say that the integral of x raised to the power of x into bracket 1 plus natural log of x divided by square root of x raised to the power of x dx is going to be equal to 2 multiplied by the square root of x raised to the power of x plus c. Awesome, right? If you really enjoyed this video, please kindly subscribe to my channel. Please do not forget to subscribe. Also like, comment, and share.